All right. Welcome to week 11, I think, of Philosophy 1500.02, Introduction to Logic Online. This week we're going to be building on what we did last week, right? We're going to be talking about syllogisms again, right, in these Venn diagram things. And we're going to talk about how to use the Venn diagrams to tell whether or not the syllogism is valid or invalid. Right, so sort of what we focused on last week was identifying form, mood, and figure, right? Now we're going to use the Venn diagrams that we learned how to fill out. So in some ways it shouldn't be like new information. In some ways it should be. So we're sort of in this weird liminal area. But yeah, it'll be fun. So stick around. All right. So I'm going to go through some examples. It turns out that these, at least the first few, are examples from the quiz, right, that was due Sunday night at 11:59 p.m. Ohio time. Right, so everyone should have completed it by now. So let this be like a way to review the quiz. So far, I'm really happy with the quiz results. So I'm doing this on Sunday evening before the quiz is actually due. But it looks like a lot of people, or most people, like understand what they're doing, and that's awesome. So, so good. Keep up the good work. But anyway, here's our first example. Here's the syllogism. Right. So some M are not P, some S are M. Therefore, some S are not P. Okay. So we want to diagram this. Right. So how do we start? Well, note that one of our premises, the first one, is particular rather than universal, right? And our rule is we always start with the universal one, and that happens to be the second one, the one that is in red here. So we're going to start there, right? So we're going to start by diagramming our second premise, no S or M. Again, right, when we have particular and universal, right, one that starts with some, right, versus one that starts with all or no, right, we have to start with the all or no one, even if it is like the second premise. Okay, so let's start with no S or M. So how would we diagram that? So what I recommend doing when you're following along in this is like set up the Venn diagram, right, and you can pause the lecture if you need to. So anyway, let's diagram no S or M. So you should come up with something like this, right? So remember that shading means that there's nothing in the area, right? So I've shaded sections 2 and 3, right? This is the part where the S circle overlaps the M circle, right? And I've shaded this part to show that there's nothing there, right? So we're told that none of the S's are M's, right? Or no S or M, right? So the parts that have been shaded would be the parts where the S's would be that are both S and M, right? And those don't exist, so we shade there. Okay, so now we can diagram our first premise, which is particular, right? So some M are not P. So what are we going to do for this? Well, we're going to use an X, right? And we're going to put the X in such a way that it shows that there's at least one thing, right, that's M, but not P, right? So we know we can't put it in the shaded area, right? Because we know there's nothing there, and the X means that there is something there. So where do we put the X? So we're going to put it in the M circle, right? Specifically, we're going to put it in the M circle that doesn't overlap the P circle, right? Because we're told that some M are not P. Ignore that no S or M is now red. Yeah. Okay, we're still talking about the first premise, right? So some M are not P, right? That means that there's some M that's not P, right? Where could that be? Well, it could be in the only remaining part of the M circle that doesn't overlap the P circle that's unshaded, which is section 1, or area 1. Okay, so once we get to this point, this is what the diagram of the premises should look like. Okay, so what are we going to do with this information to determine if the syllogism is valid or invalid? Well, think about it this way. What we've done is made a pictorial representation of the information in the first and second premise, or premises rather. So what we want to do now, right, is figure out whether or not the conclusion is true according to the drawing or the diagram, right? If the conclusion is not true according to the diagram, right, then this shows what? Well, that the premises could be true and the conclusion false, right? So sort of what we're doing here is drawing a picture, right, of the premises, right? And we're asking, is the conclusion true according to the premises? If the conclusion's not true, right, then we know that the premises could be true and the conclusion false, right? And that would show that the argument's invalid. Okay, so are the premises true? Sorry, if the premises are true, right, given this drawing, right, must the conclusion be true? That is it the case according to this drawing that some S are not P? Well, what we would want, right, is an X someplace, specifically in the S circle, right, to show that some S has some quality, specifically being not P. So, is there any X in any part of the S circle? Well, it turns out not, right? Just look. Specifically, where would we want an X? Just out of curiosity? Well, in section 5, right? Because that would be something that's S, but not P. But there's nothing there, right, according to the drawing. Right? Given all that we know, there might be something there, but not according to the drawing, right? So that means that it's possible for the premises to be true and the conclusion false at the same time. All right, and if it's possible for the premises to be true and the conclusion false at the same time, then we know that the argument is, that's right, invalid. Okay, so at this point, why do I have Boolean and Aristotelian here? Well, it turns out that there are two different sort of ways to think about existential statements, these statements about some. Right, so in this case, right, this argument is invalid from the Boolean perspective. Right, we merely have to look at the diagram to figure that out. Now, for the Aristotelian one, what's going to be important is whether there are any circles where all the parts of the circle, except for one, are shaded in. Well, in this case, there isn't. Right, there's no such case. Right, so we can just sort of move on from the Aristotelian one here. Although, for the record, it's invalid from the Aristotelian perspective. We'll come back to the Aristotelian perspective in a bit. All right, here's our second example. All M are P, all M are S, therefore some S are P. Okay, so what are we going to start with? Well, in this case, since both of our premises are universal, it doesn't matter. We can start with the first or the second. We'll just start with the first. Okay, so we want a diagram that all M are P. So how would we do that? Well, let's think about what all M are P says, right? It's saying that anything that is an M is a P, right? So consider any M you would like, it's a P. Okay, so that means what? Well, there are no M's that are not P's, right? So what does that mean, sort of in pictorial terms? How would we depict that in this diagram? So now would be a time to pause and to shade. All right, here's what you should have come up with, right? You shade parts or sections 1 and 2 of the M circle, right? All M are P. That means that nothing is an M is nothing that's an M is not a P, right? So we shade any part of the M circle that doesn't overlap the P circle. All right, here's our second one, all M are S. What does this mean? Well, it means that anything that's an M, anything that's an M, right, has to be an S, right? So there's nothing that's an M that's not an S. So where would we shade? This is your invitation to shade. All right, so we're going to shade here, right, at this part that overlaps the M and the P circle, but doesn't overlap the S circle. Okay. So let's figure out whether this is valid or invalid from the Boolean and Aristotelian perspectives. Okay, so valid or invalid from the Boolean perspective, very easy to see, it's invalid. So here's sort of the trick, right? From the Boolean perspective, any argument where both premises are universal and the conclusion is particular is going to be invalid. Right, sort of think about what we're doing with these, right? We want to see whether or not the conclusion is true according to the premises. So we draw the premises, we depict it in this sort of diagrammatic way, right? And then we ask, is the conclusion true? Well, suppose that both of our premises are universal. So that means for both of them, we're going to shade. Now, suppose that our conclusion, right, is particular. So how do we depict a particular claim? Well, we're going to use an X. Right? And if what we're looking for, right, is the conclusion depicted in the premises, we're not going to find it, right? Because we don't put any X in when we depict two universal premises. Right? So we know through that sort of reasoning, right, that any syllogistic argument where the premises are universal and the conclusion is particular is going to be invalid. Right? We can see it in this case, there's no X, right? So it has to be invalid. So let's think about the Aristotelian perspective. So there are some arguments that we call conditionally valid. So what does that mean? Well, just judging by the name, right, it means that some arguments are valid conditional on some further consideration being met. So here's what we're going to look out for. We're going to look out for diagrams where any of the circles are such that all but one part of them are shaded. Okay, so is there any part of this diagram, any circle, where all but one of the pieces is shaded? Well, yeah, right? The M circle, right? There's one part of the M circle that's left unshaded. Okay. So we want to figure out whether or not this argument is valid from the Boolean perspective. Well, we've already figured out it's invalid, but what about the Aristotelian perspective? So it turns out that this argument is conditionally valid, right? It's valid depending on whether or not some further condition is met. And we can identify that condition by this diagram, right? So remember, I said we're looking for diagrams where all but one part of the circle is shaded. So that's the M circle in this case. So what our condition is, right, for whether or not it's valid from the Aristotelian perspective and not merely conditionally valid, right, is whether or not there are any things that are M. Okay. If there are things that are M, then it's valid from the Aristotelian perspective. If there aren't, it's invalid from the Aristotelian perspective. Okay. So what we would have to do to answer the question whether or not this is valid or invalid from the Aristotelian perspective is figure out whether or not there are any M's. So of course we can't do that, right, because we haven't specified any like meaning or value for M, right? But let's think about some cases. Suppose that M were unicorn, right, or unicorns, or things that are unicorns. Are there any unicorns? Well, no, right? So this would be invalid from the Aristotelian perspective, right? But suppose that M were horses. Well, there are horses, right? So this would be valid from the Aristotelian perspective. Okay, so as it is, right, we don't know what M is. So from the Aristotelian perspective, we can say this is conditionally valid, right? And it depends on whether or not there are M's. If there are M's, right, it's valid. If there aren't, it's invalid. But all we can say right now is that it's conditionally valid until we figure out what the M's are, right? Or until it's specified for us what the M's are. So here's a third example. No P or M, all M or S, therefore no S or P. Okay, so how do we start this one? Well, again, because they're both universal, it doesn't matter which one we start with. I mean the premises. So let's just start with the first one. No P or M. So what are we going to do here? Well, we're going to shade, right? So how are we going to shade? Well, think about it. No P or M. That says that nothing that is a P is an M, right? So nothing is both P and M, right? So where would we shade here? Well, we want to shade in such a way that we show that none of the P's are M's, right? So we want to shade the part of the P circle, right, that overlaps the M circle. So that would be here. Do you see that, right? So we're told that none of the P's are M's, or no P or M, right? So we shade in the part of the circle that overlaps the M circle. Okay, good. So let's move on to our second premise. All M are S, right? So this tells us that all the things that are M are things that are S, right? So what we want to do is shade in such a way to show that there's nothing that's M but not S, right? So which part of the M circle doesn't overlap the S circle, if any? That's the part we'll shade. So which part are we going to shade? Well, this part, right? This is a part of the M circle that doesn't overlap the S circle, right? And it's the only part that's left unshaded. Okay, so now we can figure out whether or not this argument is valid or invalid, from the Boolean perspective at least. So, no S or P. According to this, right, is it true that none of the S's are P's? Well, it doesn't say, right? It might be the case. It might not be the case, right? We just don't know given the way that the circles are shaded. Okay, so it's invalid from the Boolean perspective. So let's think back to our rule for the Aristotelian perspective, right? We said what we wanted to do was find whether there was any circle, right, where 3 out of the 4 parts were shaded. But we only want to do this for certain arguments, right? Specifically, we want to do it for arguments where both of the premises are universal and the conclusion is particular. Is this such an argument? That is, are the premises universal, rather, and the conclusion particular? Well, no, right? The conclusion is universal, right? So we don't have to do this thing about asking whether or not there are any M's or whatever, right? We can just say that this is what? Well, invalid from the Aristotelian perspective. Okay. Here's another example. Some P are M, some S are M, some S are P. Okay, so in this case, note that everything is particular, right? First premise, second premise, conclusion, all particular, right? So it doesn't matter which one we start with when we're going to put x's here. So this one is going to illustrate some considerations about where we put the x's, right? So remember from the reading, sometimes the x goes on the line, sometimes it doesn't. Well, how do we figure that out? So let's start with our first premise, some P or M. Okay, so we want to put an x here that shows that there's something that's both P and M. And we only want to put one x. Okay. So where could there be something that's both P and M? So we're going to put the x here, but let's think about why we put it there. Okay, so again, where could there be something that's both P and M? Well, here's something, right? Suppose there was something that existed there. Then it would be both P and M, right? It would overlap the P circle and it would overlap the M circle. Of course, it would also be S, right? But the claim that some P or M is consistent, right, with that things being both P, M, and S. Of course, it might be the case that there's something that's just both P and M, but not S, right? In which case, there'd be something there. Okay, so given what we know here, right, by our first premise that some P or M, we can't decide which, if either of those is true. Right, we know that one of them has to be true in order for it to be the case that some P or M, right, but we don't know which one. And we can only put one x down, right? So sort of what we want to do here is split the difference, right? That's why we put it on the line, right? That's to show that we don't know if it goes to the left or to the right. That is, whether it's both P and M and S, right, or merely both P and M, but not S. So whenever you're in a case where you can put an x and there's more than one place you can put it on the line. Here's another example. Some s or m. Well, where might something be that's both s and m? Well, it turns out there are two places, right? By parity of reason. Right? It could either be to the left of where that new x is, or it could be to the right. And since it could be in either place, right, we put it on the line. We split the difference. Okay, so now we want to know, is this valid or invalid from their Boolean and Aristotelian perspectives? Well, what we want to know is it the case that some s or p according to this diagram? Well, let's think about it. So remember that where we have these x's means that there are a bunch of different ways for the associated premises to be true. Right, so this is going to be invalid. So why is that? Well, it turns out, suppose that some p or m is true and some s or m is true. Must it follow that some s or p? No, right? So suppose our x that's most to the left, suppose that we're in slot 2 or in space 2 or area 2, right? And suppose that our x that's on the line to the right, suppose that we're just in slot or area 4, right? That is, suppose that there was something that's both s and m but not p, right? And there's something that's both p and m but not s, right? That's consistent with the premises, right? So that's a way of making the premises true, but the conclusion would be false, right? There'd be nothing that's both s and p, right? So what we're sort of being asked to imagine is that there's something that's both s and m but not p, and something that's both p and m but not s, right? In which case the premises would be true, but the conclusion false, right? So from the Boolean perspective, this is invalid. And similarly from the Aristotelian, right? Remember, what we're looking for is universal premise, particular conclusion, and then 3 parts of a circle all shaded, right? We don't have that. We can conclude that it's invalid. Okay, here's another example. All p are m, no m or s, some s are not p. Okay. Is this valid or invalid? Well, let's diagram it and find out. So since both premises are universal, right, it doesn't matter which one we start with. So let's start with the first one. All p are m. So where are we going to shade here? Well, we want to shade in such a way to show that everything that's a p is m. That is, there are no p's, right, that are anything but m. Right? That is, there's nothing that's merely a p or nothing that's merely a p and an s, right? Anything that's a p has to also be an m. Okay, so where would we shade? So we'll shade here, right? These are the parts of the p circle that don't overlap m. Good. So let's move on to our next one. No m or s. So again, we're going to shade, right? It's universal. It's making a claim about all, or sorry, well, sort of making a claim about all. It's saying, of all the things that are m, none of them are s. So we're going to shade. So where are we going to shade? Well, what we want to show is that nothing that is an m is an s. Okay, so where do we shade? Well, here, right? These are the parts of the m circle that overlap the s circle, and we're told that that's empty, right? Nothing that's an m is s. So we know there's nothing there, so we can shade there. Okay, so valid or invalid from the Boolean perspective? Well, note that we have 2 universal premises and a particular conclusion. And we know from the Boolean perspective, that's always invalid. That's right. Okay, so it's invalid from the Boolean perspective. Right, sort of think about it this way. What we're looking for is whether or not there's an x, because that's what the conclusion says. There's no x, right, so it's invalid. And note that we never add when we're thinking about the conclusion. Right, at least, well, we'll find out. Okay. So it's invalid from the Boolean perspective. What about the Aristotelian? Well, note that we have a case, right, again, where the premises are both universal and the conclusion is particular. Okay, so do we have a circle, right, where where 3 out of 4 parts are shaded? Well, it turns out we have 2, right? So is it the case that there's some S that are not P? So what we're interested in this case, right, is the S circle, right? Because the conclusion says that some S are not P. So is there some S that's not P? Well, the diagram doesn't say, right? But we're in the Aristotelian framework now, so what we want to do, right, is ask whether or not there are any S's. If there are S's, right, actually, as a matter of fact, if there are S's, right, or whatever the S refers to, if there are any of those, it would be valid from the Aristotelian perspective, otherwise invalid from the Aristotelian perspective. But of course, we don't know what the S's are, right? So we can't say whether it's actually valid or invalid. We can say it's conditionally valid. But let's think about some cases. Suppose that S was pandas, right? At least for the time being, there are pandas, right? So this would be, that's right, valid. Suppose that S were dodo birds. They're extinct. Thanks, ancestors. Anyway, so there are none of those, right? In this case, it would be invalid. All right, so there are other cases where we need to look out, right? So this is just to show you sort of what it is that we're looking for. Again, note that we have 2 universal premises, particular conclusion here. One circle has all 3 parts shaded in. Which circle is that? Well, it's the M circle, right? So from the Boolean perspective, this is invalid, right? Universal premises, particular conclusion, invalid automatically. Aristotelian perspective, well, it depends, right? In this case, whether or not there are any M's. If there are, it's valid. If not, it's invalid.